You know that feeling, right? That creeping, quiet anxiety just sort of sitting at the back of your mind when you look at the latest tech news.
Oh, yeah. I think we all know that one.
Right. It's that nagging fear that artificial intelligence might actually be doing our jobs a little too well.
Yeah, that maybe the skills you spent years or, even decades painstakingly building are just suddenly about to become obsolete.
Exactly. It's a really heavy thought. And if you are feeling it, you are absolutely not alone. So today we're going to tackle that exact fear head on.
And we have an incredibly insightful piece of source material for this deep dive to help us do that.
We do. It's a narrative article by Aaron Rose. It was published on tech-reader.blog, and it's titled The Secret Life of Claude Code. Skill is not what you think it is.
Which is such a great title.
It really is. And what makes this such a fascinating read is that it doesn't just give us a dry, bulleted list of AI features.
I know, not at all.
Instead, Rose paints this very specific, very human picture. He places us right in the middle of a conversation between two software engineers. There's Margaret, who is a seasoned senior developer who has pretty much seen it all, and Timothy, her junior colleague.
And they are having this conversation in a grand Victorian library in London.
I love that setting.
It's so good. The author describes it as the kind of place where ideas are taken seriously and hype is just strictly shown the door.
Which is the perfect contrast to all the hypermodern panic surrounding AI right now.
Exactly. It's a brilliant framing device. By grounding this massive technological shift in a quiet, mentoring conversation between two colleagues, we get to bypass all the usual internet shouting.
Right, we get to focus on the actual practical reality of the work.
We get to look at what happens the day after the magic trick is performed. The dust settles and you still have a job to do.
Our exact mission for this deep dive is to unpack Timothy's existential crisis after he uses an AI coding assistant for the first time. We're going to discover exactly why the arrival of tools like Claude Code actually makes human skill more valuable, not less.
Yeah.
Okay, let's unpack this. Let's look at exactly what happened to Timothy. It's what the author calls the morning after.
A morning after, right.
So Timothy comes into work, and he is looking like a man who has misplaced something incredibly important. He is essentially having a miniature existential crisis.
And it's because of what he did the night before?
Yes. The night before, he used Claude Code to tackle a really specific problem. He had a data pipeline that was timing out whenever it hit large inputs. And just for context, if you aren't living in code every day, a data pipeline is basically exactly what it sounds like.
Think of it like a massive digital plumbing system.
Yeah, but instead of water, it's pumping millions of pieces of information like customer records or transaction logs from one part of an application to a database.
And if that pipe gets clogged or can't handle a surge in volume, the whole system just freezes up or times out.
Exactly. So Timothy feeds the context to the AI, gives it the constraints, describes the freezing behavior he was seeing, and the AI gives him a solution.
It's a working solution.
A completely working solution. The code ran perfectly, the test passed, he shipped it. It was a complete success by any standard metric.
He doesn't feel successful.
No. When Margaret asks him about it, Timothy just says, "Did I actually do anything?"
Oh.
Why is he having this reaction to what is objectively a total success?
Because that is the crux of the entire anxiety right there. And Timothy is experiencing a really profound disconnect. Think about what he actually did. He provided all the context, he outlined the constraints, he explained the exact behavior of the failing system.
Right.
And when the AI proposed a solution, he read it, he understood it, and he made the decision to push it to production.
So he did a lot.
He did. But because his fingers did not physically type the syntax of the solution, he feels like a fraud. What's happening here is that Timothy, like so many of us across dozens of industries right now, has accidentally equated typing lines of code with providing value.
He conflated the manual labor of implementation with the actual skill of software engineering.
Exactly.
I can honestly see why he feels that way, though. If you hire a baker, you expect them to physically mix the dough and bake the bread. If they just push a button on a bread-making machine, it feels a bit like cheating, doesn't it?
Sure.
Timothy asks Margaret completely seriously, where was the skill in that? He is genuinely lost.
It's a totally natural reaction, but Margaret handles it beautifully.
Right.
She doesn't just give him a reassuring pat on the back. She forces him to walk through his own process to find the answer.
Which is what a great mentor does.
Right. She asks him to explain exactly what happened before the AI even got involved. And Timothy admits he had spent an hour looking at the pipeline and had a working theory about where the bottleneck was.
But when Claude Code provided the solution, it turned out Timothy's theory was only close.
Yeah, the actual bottleneck was one step earlier in the process.
Which leads to Margaret asking him a really critical question.
Mhm.
She says, when you read the solution the AI proposed, how did you know it was correct?
Yes, that stops him in his tracks. Timothy has to stop and really think about that. And when he finally answers, he realizes that he knew it was correct because he understood exactly what the new code was doing.
He could see clearly why that specific change would fix the timeout problem.
More importantly, he could see that it wasn't going to introduce any weird new issues into the broader system, and that the solution fit perfectly with how the rest of their architecture worked.
And Margaret points out immediately that this comprehension, this ability to evaluate and validate the solution within the context of a massive, complex system, is the actual skill.
That's the job.
But Timothy pushes back, and frankly, I am with Timothy on this one. He says, but I didn't write it. He is still clinging to the idea that the physical act of writing the implementation is the core of his job.
It's hard to let go of that.
It is. Isn't this time fundamentally different? I mean, sure, we have tools, but this is a tool that is actively generating the logic itself. Doesn't that cross a new line?
What's fascinating here is how Margaret completely dismantles that idea using historical context. She reminds him that an engineer who uses a compiler does not sit there writing machine code in ones and zeros.
Okay, let's pause there for a second. For someone who isn't a software engineer, what exactly is a compiler in this context?
Think of a compiler like a highly advanced translator. Humans write code in programming languages that are readable to us, things like Python or Java. But your computer's processor only understands raw machine code, literally ones and zeros.
Right.
A compiler takes the human-readable code and automatically translates it into the machine code. Before compilers, programmers had to write much closer to that hardware level, which was incredibly tedious.
Okay, that makes sense.
Margaret also brings up modern web frameworks. An engineer today doesn't write the underlying HTTP stack from scratch every time they build a website.
The HTTP stack being the basic rules for how information travels across the internet.
Exactly. Well, I should say you hit the nail on the head. It's like the postal service. When you write a letter, you don't also have to build the mail truck and pave the roads to deliver it.
You just drop it in the box.
You just drop it in the box. Software engineering has always been a process of building on top of tools that handle the implementation details beneath us. Claude Code, in this context, is simply the very next layer of abstraction.
I hear that historical comparison. It's like moving from a dusty library of old books to staring at a sleek, modern architectural blueprint. You're no longer laying the individual bricks, you're designing the building.
That's a great way to look at it.
But I still feel like there's a difference between a mail truck delivering my letter and an AI actually writing the letter for me.
That's where the constant through all these technological leaps comes into play. The constant is judgment.
Judgment.
Yes. Think of the AI as a hyper-fast, incredibly eager sous chef in a kitchen. This sous chef can chop 1,000 onions in a minute and whip up a complex sauce perfectly.
Sounds great.
It does. But the sous chef doesn't know what the customer ordered. The sous chef doesn't know if the restaurant is out of a key ingredient for the next course or if the dish fits the overall menu.
I see.
Claude Code is a remarkable tool, but it does not give you judgment. It cannot give you the ability to look at a proposed solution and know definitively whether it is correct for your specific situation.
He doesn't know if the code is safe.
It cannot guarantee that the code will hold up under strained, unconsidered conditions out in the real world. That judgment is not downloadable. It is built slowly over time through careful, deliberate attention to the craft of engineering.
Here's where it gets really interesting, because Margaret leans in and tells Timothy that this judgment has never been more valuable than it is right now.
She argues it is actually more valuable.
Which completely flips the common narrative. Timothy points out what we are all reading in the headlines, that AI lowers the bar, that now absolutely anyone can ship code.
And Margaret gives a crucial distinction here. She says, yes, anyone can generate code now. The floor has absolutely gotten lower.
But shipping code responsibly into a live environment, that is an entirely different universe.
Let's break down her argument about the ceiling getting higher. Before AI, when a junior developer wrote poor code by hand, The damage they could do to a system was naturally limited by their physical typing speed.
They could only introduce so many bugs per hour. There was a natural friction to the process.
A natural speed limit to human error. I like that.
Exactly.
But imagine that same developer using Claude code without that crucial judgment we were just talking about. They can now generate poor, destructive code at an extraordinary speed and scale.
They aren't just creating a single bug.
No, they can introduce massive vulnerabilities or entirely flawed architectural patterns in seconds and splash them across the entire code base. So while the floor got lower, the ceiling for what a skilled developer can achieve or what an unskilled developer can destroy got massively higher.
The distance between the two has grown exponentially.
It has.
The stakes just went way up. If you bring genuine understanding to this tool, you can produce output that would have been completely impossible just a couple of years ago.
But if you lack that judgment, you are now capable of creating disasters that would have been equally impossible.
It's like giving someone the keys to an F1 racing car when they've only ever driven a golf cart.
Which is why the concept of AI as an amplifier is so crucial to this narrative. It amplifies whatever you bring to the table.
Right.
If you bring confusion, vague requirements, and a lack of deep understanding, it amplifies that into an unmaintainable mess. If you bring deep structural knowledge and clear logic, it amplifies your productivity to superhuman levels.
Therefore, as Margaret points out, the absolute most important investment a professional can make right now is not spending hours memorizing specific Claude code commands or perfectly optimizing your prompt syntax.
Because the syntax will change in 6 months anyway when the next version comes out.
Precisely. The investment must be in deepening your understanding of the fundamentals. You need to understand systems. You need to understand architecture.
You need to deeply understand how things fail and why code becomes an unreadable mess over time. Those fundamentals were true 20 years ago, they are true today, and they will be true tomorrow, regardless of what tool is generating the syntax.
That makes a lot of sense conceptually. But Timothy still has something weighing on him. You can feel the tension in the scene.
Yeah, the real issue.
He leans back, looking a bit embarrassed, and finally addresses the elephant in the room. He admits that people aren't really just worried about the philosophical definition of skill. What they're actually terrified about is opportunity.
They are worried about job security.
They are wondering if all the years they spent learning their craft still mean anything, or if they're just going to be replaced by a cheaper subscription model.
It is a very raw, very real fear, and it's not unique to software engineering. And this is where Margaret's veteran perspective is so vital. She has been in the industry for a long time. She tells Timothy that she has watched the software world absorb massive, terrifying shifts before.
She mentions IDEs.
Integrated development environments, which are basically super smart word processors for writing code that catch errors as you type. She mentions version control systems. Think of those as an infinitely complex undo button that tracks every change made by a whole team.
She also mentions the shift to cloud computing and the rise of containerization.
Yes.
Just to make sure we are all on the same page. Containerization is basically a way to package up a piece of software with everything it needs to run, put it into a standardized digital box. That way it runs perfectly, whether it's on my personal laptop or on Amazon's massive servers.
Yeah, that is a perfect summary. And with every single one of those paradigm shifts, IDEs, the cloud, containers, there were loud predictions that it would change everything and put developers out of work because it automated away so much manual labor.
But the industry didn't shrink. It exploded.
It exploded because every single time the developers who leaned into the change, the ones who took the time to learn the new tools deeply and thoughtfully, found that their opportunities actually expanded.
Because they weren't wasting time on the manual labor of server configuration or manual error checking, they became more capable.
They could solve much bigger, more valuable problems for the business. On the flip side, the developers who resisted or who stubbornly clung to the old way of doing things, they found things harder.
The tool is here. The question isn't whether or not it's going to be used. The only question left is what kind of professional you're going to be when you use it. Will you use it with deep understanding, or will you use it in hope?
Ah, yes. Timothy smiles at that word. In hope.
And Margaret delivers what is arguably the most striking line in this entire deep dive. She says, hope is not an engineering methodology.
It's such a great line.
You cannot just hope that the AI's code is correct. You cannot just hope that it didn't miss anything crucial. You cannot hope it considered all the weird edge cases that are specific to your unique users.
This raises an important question. If hope isn't the methodology, what is? Margaret is pointing out that abdicating your responsibility to the machine is a recipe for disaster.
You are still the engineer.
The AI is the assistant. If a bridge collapses, the lead engineer cannot stand there and blame the calculator they used to check the math. You have to take ownership of the output, which requires engaging with it critically, not passively.
So what does this all mean? How do we actually take this philosophy and apply it?
That's what Timothy asks.
He asks Margaret for a concrete guide. How does he actually build skill in this new AI-driven world if he isn't spending his days typing out basic functions? And Margaret gives him a very explicit, very simple new rule. She says, read the code.
It sounds almost too simple, doesn't it? But she clarifies exactly what she means by reading. You don't just skim the code to quickly approve it so you can go get a coffee.
You read it to understand it.
Every single line that Claude Code produces, you must stop and ask yourself why it made that specific choice. You check the variables. You question the logic loops.
You mentally test it against edge cases that the AI couldn't possibly know about because it doesn't know the quirks of your specific user base.
And if you don't know why it made a certain choice, it is your job to stop and find out. You have to treat every single piece of generated code as a rigorous learning opportunity, rather than treating it as a shortcut so you can bypass the work.
I have to play devil's advocate again here because Timothy pushes back, and I agree with him. Reading and dissecting 500 lines of AI-generated code, like a teacher grading a highly complex term paper, sounds like it might actually be way more work than just writing it himself from scratch.
It does sound exhausting.
Why bother using the tool if it creates a massive reviewing burden?
In the short term, Margaret completely agrees with him. Sometimes it is more work up front to review someone else's logic than to just write your own.
Right.
But if we connect this to the bigger picture, the long-term benefits are staggering. Think about the resource you are interacting with. You are now learning from a system that has been trained on an enormous, almost incomprehensible breadth of patterns, architectures, and approaches from millions of projects.
If you are paying attention, if you're reading critically, you are going to encounter elegant solutions and novel approaches that you simply would never have reached on your own.
Your repertoire expands.
You are suddenly getting exposure to senior-level architectural decisions, even if you are a junior developer, as long as you take the time to actually study what the AI is handing you.
And that is the secret. Margaret points out that the developer who uses tools like Claude Code thoughtfully now has access to a breadth of patterns that absolutely no previous generation developers ever had at that stage of their career.
It is an unprecedented learning accelerator.
You are essentially pair programming with an entity that has read every textbook and manual ever written. But it only works if you actually do the reading.
This leads to a massive shift in Timothy's perspective. You can literally feel the relief in the text. He realizes he has been looking at this entirely the wrong way. And he notices that Margaret is actually incredibly optimistic about all of this.
She is genuinely thrilled. She states that she has never had a tool that makes good thinking more productive.
She can explore a complex problem space faster. She can test out different approaches incredibly cheaply without spending weeks building them. And she can move from a raw idea to a working implementation at a speed that used to be science fiction.
For someone who genuinely loves the craft of building things, she views this as an extraordinary moment to be alive and working in the field.
Even though the AI is writing the code. Because, as she perfectly summarizes, it only writes some of the code. She is still the one who decides what needs to be built and why it matters to the business.
She's the one defining the problem clearly enough so that it can actually be solved.
She's the one reviewing the output with all of her hard-earned knowledge, catching what the AI misses, and making the final call.
She gets to keep the absolute best parts of the job. The high-level thinking, the strategy, the architecture, the puzzle solving, all the tedious, repetitive implementation details, all the boilerplate typing. She now has an excellent, tireless assistant to handle those.
As she notes, she fails to see the tragedy in that arrangement.
Skill equals opportunity. That is the realization Timothy finally lands on, and Margaret agrees.
The people building real foundational skill with these tools right now, the ones learning how to guide the AI and judge its output, are accumulating opportunity at a rate that is going to leave everyone else behind.
It is a powerful paradigm shift. Moving from a mindset of scarcity and fear, worrying that the AI is taking your job, to a mindset of abundance. The AI is taking the typing, yes, but it is leaving you with the engineering.
And it turns out the engineering was the valuable part all along. This has been an incredibly clarifying journey through Aaron Rose's narrative.
It really has.
To quickly recap what we have covered for you today, AI assistants like Claude Code are simply the next layer of abstraction in a long history of technological tools.
They do not replace human skill, they deeply require it.
Your most valuable asset is no longer your typing speed or your ability to memorize syntax. It is your judgment. Your ability to understand systems, architecture, and constraints is what matters.
And crucially, to survive and thrive, you must use AI as an incredible learning tool. Read the output it generates, understand it deeply, and expand your repertoire rather than using it as a blind shortcut to get out of doing the work.
And I think the overarching lesson here extends far beyond just software engineering. Whether you're deep in code or you are navigating the introduction of AI in marketing, finance, law, or any other field, the principle remains exactly the same.
Leaning into the tool thoughtfully, mastering the fundamentals of your craft, and applying rigorous judgment to the AI's output is exactly how you protect and dramatically expand your own opportunities in the future.
It is about becoming the architect rather than the bricklayer. But before we wrap up this deep dive, I want to leave you with a lingering, somewhat provocative thought based on everything we have just discussed.
Tear it.
We have established that the future belongs to those who exercise judgment and decision-making over tedious implementation. But here is the challenge. If artificial intelligence successfully strips away all the tedious execution of your daily work, leaving you entirely with the high-level tasks of judgment, decision-making, and problem definition, how will you learn to feel productive at the end of a day when your hands have barely touched the keyboard?
It is a whole new way of working.
And a whole new way of valuing ourselves. Something to think about.